going to study chemistry subject, and this is session number 9 belonging to the same chapter, which is aliphatic hydrocarbon. Now in this session we are going to get emphasize upon the topic so called as cis addition via through alkaline cheminophore, right? So here the addition will be going to take place through cis. Cis means the same side, that I am going to make you understand, by utilizing an alkaline potassium permanganate, and trans addition will be going to get happen towards the olefin by utilizing bromine water. Now this concept will be the last concept of unit alkene. Okay, so this will be the last concept for that particular unit. Okay, now in this cis addition, first we are going to emphasize more focus upon the first one, cis addition by utilizing alkaline potassium permanganate. So this reaction basically takes place through a process called as oxidation. Now what do you understand by the word oxidation? Oxidation is a process in which the oxygen will be going to get added to the reactant. Okay, so in order to bring about the oxidation process, what we need? We need oxidizing agent. Now what is oxidizing agent? The oxidizing agent is nothing but the particular agent which brings about the oxidation of the another species and itself undergoes reduction, right? So that is the meaning of the word oxidizing agent. Now the most important oxidizing agent is cheminophore. There we have written cheminophore. So that cheminophore is nothing but called as potassium permanganate. Okay, whereas the another oxidizing agent will be K2Cr2O7, which is called as potassium dichromate. Okay, so these are the two important oxidizing agents which is helping out to bring about the oxidation of olefin. Okay, olefin means what? Olefin is basically an alkane. Okay, now this oxidizing agent wherein we have been written on the board, we are going to utilize cheminophore over here. Potassium permanganate. Now this potassium permanganate has a tendency to produce an oxygen, and the oxygen is produced in the form of a nascent form, right? So why we are utilizing the oxidizing agent? Because it has a tendency to produce nascent oxygen. Now what is the meaning of the word nascent oxygen? The singlet oxygen, which is really highly reactive. Okay, so thereby the nascent oxygen will be going to get produced when we take an oxidizing agent so called as cheminophore, which is potassium permanganate. Okay, now children, here when potassium permanganate, when it is treated with an alkene, this potassium permanganate either it is taken in the form of a diluted cold potassium permanganate, they are utilizing, so that time you will get certain product. Okay, or if you are taking cheminophore into concentrated hot potassium permanganate, if you are utilizing, you are going to get obtain another product. So the product obtained by utilizing this oxidizing agent, they will be totally different from each other. See, they are utilizing the same oxidizing agent, but the condition applied over there is in dilute cold one you are going to get obtain the another product, whereas in concentrated hot cheminophore you are going to get obtain the another product. Okay, so in your syllabi we are going to study only about the diluted cold cheminophore. Okay, we are not going to focus upon the concentrated hot KMnO4. When this is going to get treated with olefin, you are going to get obtain another product. Okay, so we are going to get emphasize upon only when we are utilizing diluted, cold KMnO4, that certain important product is going to get obtained, that we are going to study over here. Okay, so now let's carry on towards the another topic, another state. So here, as I said, potassium permanganate is having a tendency of producing nascent oxygen. Now how that potassium permanganate produce the nascent oxygen, let's understand that. So here in first step, when potassium permanganate KMnO4, okay, is treated with water, it will produce potassium hydroxide plus manganese dioxide plus 3 nascent oxygen. Okay, so this is how the oxidizing agent first produce the nascent oxygen. Now the nascent oxygen which has been produced by the oxidizing agent, when we add into the water, you can see here potassium hydroxide is formed, and this one is manganese dioxide, and the third product, main product which has been formed over there is the nascent oxygen. Now that nascent oxygen has to react with the olefin. Okay, now the olefin I am going to take over here is, what is the name of this olefin or the name of the alkene? Yes, the name for this is ethene or ethylene. Okay, so when that nascent oxygen is treated with the olefin in presence of water, that time and product will be going to get formed where the 2OH, now here in this 2OH is going to get formed, hydroxyl ions. Now here if you combine this, there are 2 hydrogen and 2 oxygen, so thereby they will obtain the 2 hydroxyl group over there. Now this 2 hydroxyl group will approach towards the each carbon atom into the ethene, so they are going to get approach and get added to each carbon atom to form a main product which is called as ethylene glycol. Okay, so this is the main product. And now you have to get one question over here, or one question should arise in your mind. The topic is saying cis addition. Cis addition is going to take place. Now here cis means what? In this case, the groups, the similar group will attach towards the same side. They will attach towards the same side of the carbon atom. Now here the most important 2 groups were hydroxyl group. This 2 hydroxyl group will approach towards the 2 carbon atoms in the same side. Are they added towards the different carbon atoms in a different sides, in opposite sides? No. The 2 hydroxyl group has been approached and attached towards the 2 carbon atom in the same side. Therefore, it is nothing but called as a cis addition. Now here, one more thing I would like to add to you here is that we said the KMnO4 is used as a main oxidizing agent. But this, one more thing I would like to add is that if we took dilute alkaline, right? Alkaline, or first I'll write the word cold alkaline rather than dilute alkaline, cold alkaline, because we are focused upon the cold, right? So dilute cold alkaline KMnO4 is utilized over here. Right? So this dilute cold alkaline KMnO4 has one particular name for this reagent, which is called as Bayes reagent. Bayes reagent. Now, this Bayes reagent is nothing but a dilute cold alkaline KMnO4 solution is nothing but called as Bayes reagent. Now, this reagent plays most vital role in detecting whether that particular sample contain any unsaturated carbon atom into it. Right? I repeat once again, if anybody gave you one sample, particular sample, okay, now if I want to detect whether that particular sample contain any unsaturated, group over there, unsaturated group means alkyne, if it is present into that sample, basically I'll focus upon only the alkyne, unsaturated groups. So that time, when you treat that sample with the Bayes reagent, when you treat that sample with the Bayes reagent, now what does the Bayes reagent contain? What does this Bayes reagent will contain? It contain alkaline KMnO4, cold alkaline KMnO4. Now KMnO4 is present over there in the medium, alkaline medium. That time, as we know that potassium per magnet is purple in color. It is purple in color. So the moment when alkene oriented sample you add into the KMnO4 solution, the purple color of the KMnO4 will convert into brown color. It will going to get vanish into the brown color. Why it is so? Because as we know that it will form the most important component, which is called as a manganese dioxide. So when an alkene containing sample treated with the potassium dichromide, so that time the purple color of the KMnO4 is going to get vanished and brown coloration will be going to get obtained from the test because of the formation of manganese dioxide, which says that, which is a confirmatory test in fact, which says that the sample is containing unsaturated carbon atoms into it. Okay, so this is a test, Bayes test, which suggests or give the prediction whether the particular sample is containing the unsaturated carbon atom into it or not. Okay, so that was all about the cis addition of alkaline KMnO4 is taking place, but via through the same side. That's why its name is cis addition, and this is basically taking through a process called as oxidation, right? A process called as oxidation to form a most important compound called as ethylene glycol. Now this ethylene glycol which has been formed, here you can see the two OH group are there, right? So thereby in the product, if the two OH group is there, so that time this process is also called as a glycolization, or it is also called as a hydroxylation, right? So this process are termed either by two names, glycolization or hydroxylation. Hydroxyl means OH. Glycolization, from the product you can see glycols are formed, wherein you can write down the IUPAC name for that. Ethylene glycol can be written by an IUPAC name, so called as, and this is first carbon, this is second carbon. The IUPAC nomenclature for this will be, the IUPAC nomenclature will write down, name will be 1, 2 diol or ethane diol, or you can see here two carbon groups are there, right? So it is ethane, in place of E it will be diol, right? Or if you want to write only with the common name, you can write down only the common name for that, which is ethylene glycol. Okay, now let's take one more example for this. This is really very important, children, from examination point of view. So let's take one more example for this. So I guess you guys have been understood with this. So I'll take one more examination examples. So the olefin which I took over there was ethene. Let's take the another olefin whose name is propene. So this is prop 1N. So this propane, when it is treated with the nascent oxygen in presence of water. Now the first step will be the common one. So we are going to emphasize only upon the second step. Okay. So here we know that the addition of hydroxyl group will be going to take place between carbon-carbon double bond. Right. So this is carbon number 1, carbon number 2. So between these two carbon only, the addition of OH group will be going to take place. So here CH3 will not going to get changed. So it will remain constant. So here the CH, and you can see the 2 OH group will be going to get added over here. So the 2 OH group will be going to get added in this manner. So this is how the addition will be going to take place, which have been formed over here, wherein 2 OH group has been attached to this carbon-carbon double bond. They have been attached in this manner. You can see on the board. The name for this product will be propylene glycol. Propylene glycol, which has been formed in the same manner wherein I have written over there. Now, as you know, in the first step, the nascent oxygen has been, formed from which main important reactant? Yes, potassium per magnet. Now, this oxygen, the nascent oxygen has been coming from what? KMnO4, potassium per magnet. And here also this oxygen which has been, I have written over there, that is also coming from the first step, which is from KMnO4. Okay, so this is how the cis addition of OH group will be going to take place across the carbon-carbon double bond in an olefin, and by utilizing the most important reagent, which is base reagent, right? And this base reagent is helping out to predict whether that particular sample is containing any unsaturated carbon atoms into it. Okay, so here we done with the first topic of this main concept, which is cis addition alkaline KMnO4. Now let's emphasize upon the second topic, which is trans addition of bromine. Trans addition of bromine we'll understand. So in trans addition, now in cis addition what was happening? The 2 groups were getting attached to the olefin towards the carbon-carbon double bond from the same side. Whereas in trans addition, which is also called as anti-addition, that will be going to get occur, okay, from the opposite sides. From the opposite sides between the carbon-carbon double bond. Let's understand that by taking one example over here. Okay, now trans addition by utilizing the main important component, which is bromine water. Okay, now here in trans addition what will happen? Yes, I'm going to take a simpler example, which is the alkene. And the name for this alkene is ethene or ethylene. It is also called as ethylene. Now, in this ethene, when I add bromine water is containing what? Yes, bromine, Br2, in presence of a solvent called as carbon tetrachloride. So that time, what will happen is that this bromine atoms are there. They are going to get attached to the carbon-carbon double bond, between the carbon-carbon double bond, in anti-position. In anti-position means from the opposite sides. So here you can see when they are going to get attached, they are going to get attached in this manner, in anti-position. Okay, and there is a certain big mechanism for that. So here these 2 bulky groups are going to get approached towards the carbon-carbon double bond from the anti-position, because if 2 bulky groups, Br is literally a bulky group. If 2 Br group, they are going to get approached towards the carbon-carbon double bond from the same side, there will be certain steric hindrance. What do you understand by the word steric hindrance? Steric hindrance means repulsion will be there. Apart from that, they won't have the particular space and they becomes totally unstable. They are going to get approached from opposite sides towards the carbon-carbon double bond, and from mechanism also you can go through the same thing. Okay, so this is how the product will be going to get formed by anti-addition. Anti means what? Trans-addition, okay, of bromine towards the olefin. So the name for this will be, now this is carbon number 1, carbon number 2. So the name for this, 1, 2, how many bromo are there? 2 bromo are there, right? So dibromo, and the parent alkane is what? Ethane. So it will be written in this manner. Okay, so this is how the reaction will be going to get proceed in this manner. So let's take one more example for this. Let's take one more example. I'm going to take a propylene. This is what? This is propene. Okay, prop 1N. Prop 1N. So when this prop 1N is treated with bromine water in presence of carbon tetrachloride, so that time we know that the addition of bromine atom will be going to take place between carbon-carbon double bond, right? So, and the addition will be going to take place from the trans side, that means from the antiposition, opposite side, right? So here we will obtain a product like this. Okay, so one bromine atom will attach here, the another will be going to get attached upside. That is nothing but called as anti-addition or the trans-addition. So the name for this product is nothing but, so 1, 2, 3. So at 1 and 2 position, bromo is there. So 1, 2, dibromo. Parent alkane is 3 carbon. 3 carbon oriented alkane is propane. So it will be propane. Okay, so this is how the anti-addition or trans-addition of bromine water will be going to take place towards the olefin. Now, how the Bayer's reagent was utilized, or alkaline KMnO4 solution is utilized to predict whether any particular sample is containing the olefin into it or unsaturated carbon into it. Here also the bromine water is utilized for predicting or for testing whether that particular solution is containing any unsaturated carbon atom into it. So how that particular test will take place, let's write down over here. Now bromine water is basically brown in color, basically not brown but little, I can say a little yellowish, darker, deep yellowish, okay, deep yellowish. Now this deep yellowish oriented bromine water, when you add into alkene containing sample, that going to get disappear in the sense that deep color of, coloration of bromine will become faint. Okay, so that gives the test for any unsaturated oriented compound containing into the sample. So that gives the test for the bromine test. Okay, so this is how the cis addition of by utilizing alkaline KMnO4 is can be obtained, and trans addition of olefin can be obtained by utilizing bromine water. Okay, so this we have been winded up, and yes, alkene unit has been completed. So let's go towards the another unit, which is alkyne. So alkane, alkene. So do not get confused with these words. Alkane we have been completed, whereas alkene just now we have been completed. Now we will start with third one, alkyne. Okay, now once we complete with this alkyne also, then the chapter will be going to get winded up. Now let's focus upon the next third unit, which is alkyne. Okay students, now let's start with a new concept, with a new unit, which is an alkyne. Now what do you understand with the word alkyne? That we need to understand, and there are certain general formula for this alkyne, and apart from that we should study the 5 members belonging to this family called as alkyne. Okay, so what do you understand by the word alkyne? Now alkyne is nothing but alkyne is an aliphatic hydrocarbon. Aliphatic basically unsaturated hydrocarbon. Unsaturated hydrocarbon containing at least one triple bond. Containing at least one triple bond. So what is the alkyne? Alkyne is nothing but it is an aliphatic. Aliphatic means open chain. Unsaturated means it contains certain triple bond between the carbon-carbon atom. So it is an open chain, unsaturated hydrocarbon basically containing at least one triple bond between the carbon-carbon atoms. Okay. So like alkane, alkene, alkyne are also having the general formula, and basically it is a family, and into that family how that 5 members will be going to get derived by utilizing the general formula. So the general formula, this is point number 1. Point number 2 is the general formula for alkyne is CnH2n-2. So this is the general formula for the alkyne, where N stand for number of carbon atoms. Number of carbon atoms into that alkyne. Okay, so by utilizing this general formula, we are going to derive the first 5 members of the alkyne. So let's go with the first member of alkyne. Now the first member of alkyne will start from number of carbon with 2. Okay, the first member for that particular alkyne begins with the number of carbon with 2. So I am going to start by taking C carbon as 2. If 2 number of carbons are there, if the 2 numbers of carbon we are going to take over there, the N will definitely be T2 into the general formula. So what is the general formula for the alkyne? CnH2n-2. So let's substitute this N into this general formula. So N is 2, H 2 into 2 minus 2. So this becomes C2, 2 2s are 4, 4 minus 2 is 2. So this is the molecular formula for the first member of alkyne family, and the name for this member is ethyne. Y-N-E. Ethyne, understand this. Okay, so this becomes the first member, and the common name for this is acetylene. Acetylene, the common name. Okay, now if I wrote the general molecular formula for that, there will be structural formula as well. So the number of carbon is 2, so 2 carbon atoms are there. Between the carbon atoms, yes, obviously triple bond, which is the identification that this is an alkyne. From alkyne only we saw over here, at least one triple bond should be present between the carbon-carbon bond, which makes it unsaturated. Okay, so this carbon-carbon bond, triple bond will be there, and how many hydrogen is there? Yes, obviously 2 hydrogen, which is written in this manner. Okay, so let's go towards the second member of alkyne family with the carbon is equal to 3. Okay, so if 3 is the number of carbon, the N will be 3, obviously. So let's write down the general formula for this, CnH2n-2. So let's substitute this N with 3, H2 into 3 minus 2. So C3, H, 2 3s are 6, 6 minus 2 is 4. So this becomes the molecular formula for the next member, which is 3 carbon atom is there, right? So the name for this, propyne. Propyne. Okay. If the molecular formula is given over here, let's write down the structural formula for this. Structure. Okay, open chain compound. So 3 carbon atoms, 1, 2, 3. Okay. Now I am going to add this triple bond between carbon number 1, carbon number 2, and this will be carbon number 3. Okay. Then how many hydrogen are there? Yes, totally 4 hydrogen. Now the 4 hydrogen need to be added in very precise manner, because we know that each carbon atom has a valency of 4, means it can get combined only with the 4 other atoms. Now other atom wherein I am going to utilize over is hydrogen. So it will going to get combined only with the 4 hydrogen atom. And now one bond is already utilized to get attached with the adjacent carbon atom. So only 3 bonds are left with each carbon atom. Okay. Now if I compare with the carbon number 3 here, one bond is already utilized to get bonded with the carbon number 2. So here it will have only 3 bonds which will be going to get utilized to get combined with the remaining number of hydrogen atom. So here 3 hydrogen atom, it will be utilized in this manner. Okay. Then if 3 hydrogen is utilized, number of hydrogen atom is 4. 3 is already utilized. Let's go towards the carbon number 2. Now in carbon number 2, how many bonds are there? Let's see. Here 1. This carbon number 2, one bond it is getting shared with the carbon number 3. Whereas the remaining 3 bonds are getting shared with the carbon number 1. So thereby carbon number 2 valency is satisfied by getting attached with the other carbon. So no hydrogen atom will be going to get attached to the carbon number 2. Why? See here, 1, 2, 3, 4. So this is how the valency will be going to get satisfied for the carbon number 2. Whereas for carbon number 1, you can see the 3 bonds are getting shared up with the carbon number 2. So this 3 bonds means 3 bonds are already utilized. Only 1 bond is left which is going to get attached with the remaining number of hydrogen atom. So totally 4 hydrogen which are there, they are going to get bonded with each carbon atom in this manner. So only the terminal carbon atom is getting binded with the hydrogen atom. Carbon number 3 will get bind with the 3 hydrogen. Carbon number 1 will get bind with the 1 hydrogen. So the name for this is, yes, propyne. But if I want to specify the position of yne, yne means what? Triple bond. Okay. So propyne. Yne means what? Triple bond. The triple bond is present between the carbon number 1 and carbon number 2. So lowest preference I am going to give. So it become prop 1 yne. Done. So this is the second member of alkyne family. Now let's go towards the third member of alkyne family with carbon is equal to 4. Therefore N will be 4. Okay. So you need to substitute this N with the 4 into the general formula. The general formula is CnH2n minus 2. Correct. So let's substitute this N with 4. So C4NH 2 into 4 minus 2. So this becomes C4, 2 4s are 8, 8 minus 2, right? So C4H, 8 minus 2 is 6. So this becomes the molecular formula for the third member, whose name is butane. Butane. Okay. So for if we wrote with the general formula, the molecular formula, sorry, so we need to understand the structural formula for this. Now the structural formula will be as such. Now 4 carbon is there, right? So let's write down first 4 carbon. 1, 2, 3, 4. 4 carbon is written in this manner. Okay. Now how many number of hydrogen is there? 6. Now if I want to give the triple bond between like this, 1, 2, 3. Between 1, 2, 3, 4. Between carbon number 2 and carbon number 3, if I want to give the triple bond in this manner, so we need to balance each carbon atom with the remaining number of hydrogen atom. Now let's start with the carbon number 1. Carbon number 1 is getting attached to the carbon number 2 by sharing its bond. Okay, so one bond of carbon is already utilized. So how many is remaining over there? 3. So the 3 hydrogen atom will be going to get attached to this first carbon. Now let's talk about the carbon number 2. In carbon number 2, one bond is already attached to the carbon number 1, and the remaining 3 bond, you can see it is attached to the carbon number 3. So the carbon number 2 is sharing its bond to the another 2 adjacent carbon atom. So thereby its valency will be going to get satisfied with 4 bonds. Then so here no hydrogen will be going to get attached to the carbon number 2. Whereas in carbon number 3, here also you can see 1, 2, 3. 3 bonds of carbon number 3 is getting shared up with the carbon number 2, and the remaining 1 bond is getting shared up with the carbon number 4. So no bond will be going to get attached to the carbon number 3 to add any hydrogen atom over there. So let's go towards the terminal one. Terminal means the end carbon atom. Here only 1 bond of carbon number 4 is getting attached or shared up with the adjacent carbon atom. So how many more is left? 3 hydrogen. So the 3 bond will be going to get attached to the remaining 3 hydrogen atom. So in this manner, the bond formation, how many hydrogen was there? 6. So you can see 6 hydrogen has been attached towards the terminal carbon atom, towards the end carbon atom. So this is how the structure will be there for butane. But here the name will be different, because we need to give the position of that particular triple bond between which carbon atoms the triple bond will be going to get present. That is very, very important over here. So the name will be as such. So if you start labeling from here 1, 2, 3. So between carbon number 2 and carbon number 3, the triple bond is present. So the name will be as such, but. Now ine means triple bond. Triple bond is present between carbon number 2 and carbon number 3. So I am going to take the lowest preference, which is 2. So but2ine is the nomenclature or the naming for this structure. Suppose if anybody give another structure with C4H6 molecular formula, how will be the naming for that particular butane structure? So the naming will be going to get differ depending upon the position of the triple bond over there. Now with the same molecular formula, if the triple bond is present between the carbon number 1 and the carbon number 2, so how it will be there? Let's see over here. Now this is carbon number 1, 2, 3, 4, right? So the bond formation will be there into such a way that the terminal hydrogen will get this. Okay, yeah, this is wrong. I'm going to making the structure different, right? So the number of hydrogen atom will be different. So carbon number 1 will have, this is first, okay, carbon number 1 is having 4 bond. Carbon number 2 is also having 4 bond, 1, 2, 3, 4. Whereas in carbon number 3, you can see over here 1, 2, remaining 2 will be here, right? So carbon number 4 will have 3. So this is how the 6 hydrogen will be going to get distributed. You can see 1, 2, 3, 4, 5, 6. Okay, done. So the name for this will be but. Yes, the triple bond is present between carbon number 1 and carbon number 2. So which preference I should give? Yes, exactly, 1 in. Correct? So this is how the butane will be going to get given with this structure. Okay, now let's go towards the last member of this alkyne family with C is equal to 5. Okay, so 1, 2, 3, 4. No, third one is over. Now this is, yeah, fourth one. So we are going to study the first 5, second last one. With carbon number 5, if I am taking carbon as 5, so N will become 5. So its general formula will be CnH2n minus 2. So let's substitute over here C5H2 into 5 minus 2. So it will become C5H10 minus 2. So this becomes C5H. 10 minus 2 is 8. So this is what the molecular formula for the next member. So you just have to substitute N as 5 and you need to derive one molecular formula. So the name for this molecular formula which I have written over here, since 5 carbon is there, the name will be pentyne. Pentyne will be the name for this molecular formula. So let's go towards the structural formula for this pentyne. So I guess you people are writing down along with this, because these are really very basic members of alkyne. If you know them, then only you can carry out the chemical reaction or certain things to understand in more detail about the alkyne. If you don't know the basic members of particular unit, you are not able to study the chemical reactions along with the mechanism. So you should know the basic members of each and every unit, so called as alkane, alkyne and alkene. Okay, so let's go towards the pentyne structure over here. So pentyne is having 5 carbon and 8 hydrogen. So the 5 carbon and 8 hydrogen oriented structure will be as such. So 5 carbon are there. So let's write down the 5 carbon. 1, 2, 3, 4, 5. Done? Okay. Now if I want to give the triple bond between, like this, triple bond, okay, then the remaining carbon atom will be going to get shared up by having the bond with the adjacent carbon atom. Okay, so the numbering will be as such: 1, 2, 3, 4, 5. Okay, because the triple bond should get the lowest preference. So if you give in the reverse manner, it will get 1, 2, 3, 4. So between 3 and 4, the triple bond will be there, which is we are not going to take. Okay, so the lowest preference should get. Now the remaining bond should be satisfied by getting attached with the number of hydrogen atom. So let's talk about the carbon number 1. Here already one bond is utilized, then the remaining 3 will be utilized for getting attached with the 3 hydrogen. Carbon number 2, you can see 1, 2, 3, 4, done. Carbon number 3, 1, 2, 3, 4, done with the carbon number 3 also. Now let's talk about the carbon number 4. Here already 2 bonds are there, so the remaining 2 bonds will be getting satisfied by getting attached to the 2 hydrogen. Whereas the terminal carbon atom, it is already getting attached with the 4th carbon atom. So the 3 bonds will be going to get attached to the 3 hydrogen atom. So this is how the structural formula will be going to get derived with the molecular formula C5H8. So the number of hydrogen atom which is combined into this structure is 8. So let's see how many are there. 1, 2, 3, 4, 5, 6, 7, 8. Correct. Yes. So the name for this is, yes, the name will be pentyne only. But the position of yne means the position of triple bond is very, very vital over there. So pentyne will be given in, the position is present between 2 and 3. So pent 2 yne. Okay. Done. So this is how the thing is going to get happen over here. Okay. So if pent 1 yne should be there, so what you will do? The triple bond should be present between carbon number 1 and carbon number 2. Okay. If pent 3 yne if you want, then triple bond you have to add between carbon number 3 and carbon number 4. But remember, whenever you are adding triple bond between the particular carbon atom, you should think about the valency of that carbon atom only. Okay, so that is really very, very important, guys. So we have been done with the 4th member of the alkyne family. Let's go towards the 5th member, the last member. Actually this is not the last, but as per your syllabus, the first 5 member you should know it first. So the 5th member of this alkyne is, with C is equal to 6, so N will be 6. So let's substitute in the formula N. So CnH2n minus 2. So this is the formula, general formula for the alkyne. So let's substitute N with the 6 over here. CnH2n, 2 into 6 minus 2. So this becomes C6, H2 into 6 is 12 minus 2. So this becomes C6, H12 minus 2 is 10. So this is the molecular formula for the fifth member of the alkyne family, which is what the name will be, hexyne. Hexyne. Yes, hexyne. Yeah, now when you are writing down the structure, the position is very, very important. So let's write down the structure for this fifth member of the alkyne family. So we'll just do with the hexyne structure. So 6 carbon is there. So 1, 2, 3, 4, 5, 6. Done with the 6 carbon? Okay. Now if I want to give the triple bond over here, okay, then remaining carbon atom will be going to get balanced out by getting attached with the neighboring carbon. So let's number first. The lowest preference we should have to take 1, 2, 3, 4, 5, 6 in this manner. 1, 2, 3, 4. Yeah, anyway round, the triple bonded compound is present between carbon number 3 and 4. Here also 3 and 4, right? So anyway round, if you take the forward direction numbering also okay, reverse direction is also okay. Then the remaining valency will be going to get satisfied by getting attached to the number of hydrogen atom in that which is present in your molecular formula. So the first carbon will attach to the 3 hydrogen atom. Why 3 hydrogen atom? Yes, you can see over here in the structure already one bond has been attached to the neighboring carbon. Whereas the second carbon will be going to get attached to the 2 hydrogen. Yes, you can see 4 valency. Now let's talk about the third carbon. Third carbon, here 1, 2, 3 is there and 4. No hydrogen will go and get attached to carbon number 3. Whereas carbon number 4 also, here also 3 bond is attached and 1 bond is already attached to the carbon number 5. So no hydrogen atom will be going to get attached to the carbon number 4. Then 5, 1, 2, 2 hydrogen over here, and then carbon number 6, 3 hydrogen over here. Done? So this is how each carbon atom will be going to get valency balanced by getting attached with the number of hydrogen atom which is present over here. Now number of hydrogen atom present over here is 10, right? So let's count over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. Right? Done with the structural formula. Suppose if you want that triple bond to present between carbon number 2 and carbon number 3, the position of bond you need to write down. Apart from that, while writing down the structure, you have to take precaution that each carbon should be, valency should be balanced over there. You should not have to balance the disturb the balancing of the valency over there. You know that only each carbon can make 4 bond because its valency is only 4. So these are the 5 particular members of alkyne family. Okay, now I think we have been done with this. So the remaining next topic will begin with the next session, which will be the session number 10, wherein we are going to study about the preparation methodology of alkyne and then chemical reaction of alkyne. Okay, so these 2 topics we are going to get study into the next session, and into that also some methodology will be there, that also we are going to get study over there. So thank you class for watching this class. Thank you so much.